Hello, hello, hello. Very good evening, good afternoon, good morning, sir. Same slogan you are saying daily. We are getting bored. Okay. How are you all? Sir, good, sir. Good. Now, in today class, I am going to start alcohol phenol ether, and in this topic, I will complete total about alcohol, like their method of preparation, their chemical properties, their physical properties, each and everything about the alcohol I will cover in this class. So this is the topic of total one sort of alcohol. Now basic things you already know कि CH3OH is 1 degree primary methyl alcohol, CH3CH2OH is 1 degree ethyl alcohol, CH3OH isopropyl alcohol, CH3CH2CHOH CH3 secondary alcohol. This is 1 degree, this is 1 degree, this is iso, this is secondary. After that, ringa, chinga, pinga, hinga, linga. This is neo, ringa, chinga, pinga, hinga, linga. This is 3 degree tertiary. This is 2 degree. Secondary means 2 degree. It is neo. After that, you know that whenever I will write over here CH2OH, it is known as 1 degree benzylic alcohol. Suppose I will write over here CH3CHOH 2 degree benzylic alcohol. Over here CH3OH 3 degree benzylic alcohol. As well as you know that this alcohol is known as glycol and this alcohol is known as glycerol. So basic things you know about alcohol कि first one is 1 degree, second one is also 1 degree, this is iso, this is secondary, this is neo, this is 3 degree tertiary, this is 1 degree benzylic alcohol, this is 2 degree, this is 3 degree, this is glycol, this is glycerol. More than that, we didn't have to know about that much of alcohol. Now, after having this basic introduction that everyone is already familiar with, now I am going to start method of preparation of alcohol, and everyone will see this very properly. This topic I am going to dictate mains plus advance. Means after reading out this topic you will not find any one of the difficulty in this topic. Means this topic will become the most easiest topic of all time. You will enjoy alcohol phenol ether if you will understood it what I am trying to dictate. Okay sir, first of all we are going to see method of preparation of MOP, means method of preparation of alcohol. Now if we will have to prepare alcohol, what are the logic, what are the method we will follow to prepare alcohol? First method to prepare alcohol is see over here, either this lecture will go 1 hour or this lecture will go 2 hour or this lecture will go 3 hour. Not that much, but just I am saying I will dictate each and everything very properly. If you want to see it, see, otherwise you can go, no problem. Choice is yours. There is no pressure in that. From hydrocarbon means what? Either it should be alkane, it should be alkene, or it should be alkyne. Basically we have to study from alkene. Okay, so there are 3 methods to produce alcohol from hydrocarbon. There are 3 methods to produce alcohol from hydrocarbon. First method is known as acid catalyzed hydration. First method is known as acid catalyzed hydration. Acid catalyzed hydration we will use dilute H2SO4 or we will use H plus H2O. Second reagent is hydroboration oxidation. High acid catalyzed hydration, short from ACH, acid catalyzed hydration. Over here second one is hydroboration and oxidation. Hydroboration and oxidation. hydroboration and oxidation covers small short tricks is HBO. Hydroboration, oxidation. Third one is oxymercuration and demercuration. Oxymercuration and demercuration. Oxymercuration, demercuration, short form OMDM. Means there are three methods to produce alcohol from hydrocarbon. First method is called oxymercuration, acid catalyzed hydration, that is ACH. Second method is called hydroboration oxidation, that is HBO. Third method is called oxymercuration and demercuration. These all reagent will give what? Alcohol. First reagent has a property कि it will form carbocation. What it will form? Carbocation. And if it will form carbocation, then it will do rearrangement. I will do questions also, don't worry about it. But first I am writing all the important point. Second important point, reagent is H plus H2. Okay. Now over here, second reagent we have hydroboration oxidation. For hydroboration oxidation, the reagent we will use is first BH3 in presence of THF. THF means tetrahydrofuran. This is the structure, tetrahydrofuran. Plus second reagent we will take H2O2 in presence of NaOH. In this reagent you have to understood first important point that no carbocation. No carbocation. Over here carbocation is not formed, as well as Markovnikov rule we follow. Markovnikov's rule will be followed. Sorry. Hydroboration oxidation, anti-Markovnikov's. Over here we will follow. Acha, first one is the correct. No carbocation. No carbocation. Second important point, no carbocation means no rearrangement. Understood? Don't get confused. Third important point, it will do anti-Markovnikov's rule. Third important point, it will do syn addition. Hydrogenation, hydrocarbon, syn addition, anti-addition. Syn will taken as a positive, anti will taken as a negative, and cis will taken as a positive, anti will taken as a negative. That I will dictate, don't worry about it. Then last part of the topic is called oxymercuration demercuration. Oxymercuration demercuration, it will also not form carbocation. No carbocation. Why? Because of oxymercuration will form non-classical carbocation. In hydrocarbon I have dictated this. Then if no carbocation means no rearrangement. No carbocation means no rearrangement, and this will follow Markovnikov's rule. This will follow anti-Markovnikov's. This will form carbocation. Don't get nervous and confused. Now over here, see, I am writing some flow chart, then after that I will dictate the question also. Means what I am trying to say, कि first of all in acid catalyzed hydration, what is the reagent you are using? H plus H2O, or you are using dilute H2SO4. So SO4 is giving H plus, and dilute means water. Water is giving OH minus. Over here we are using the reagent BH3THF. On the top I have written this BH3 and THF will give H. BH3, THF not, and H2O2 in presence of NaOH. This H2O2 will give OH. Similarly in oxymercuration demercuration, we are using the reagent. First reagent we are using is HgOAc whole twice in presence of H2O. HgOAc whole twice in presence of H2O. Second reagent we are using is NaBH4 in presence of NaOH. You have to know कि over here H2O will give OH and NaBH4 will give H. Understood what I am trying to say? I am saying that first of all, don't get confused. This is based and easy. First of all, I have dictated you the basic part of alcohol. What is 1 degree that I understood, sir. Now, method of preparation of alcohol from hydrocarbon. Hydrocarbon means what? Hydrogen and carbon containing compound will be alkane, alkene, and alkyne. 3 reagent we will use: acid catalyzed hydration, hydroboration oxidation, and oxymercuration demercuration. First of all, in acid catalyzed hydration, we will use dilute H2SO4 or H plus H2SO4, in which H2SO4 will give H and H2O will give OH. This you have to know. Similarly, over here, BH3 will give H and H2O will give OH. BH3 will give H and H2O2 will give OH. Similarly, oxymercuration demercuration, H2O will give OH and NaBH4 will give H. This part understood. Then it will form carbocation rearrangement. No carbocation, no rearrangement, anti-Markovnikov rule, syn addition. Very important. Then no carbocation, no rearrangement, because non-classical carbocation, Markovnikov's rule it will follow. If you will understood this flow chart, then on this basis of flow chart, I am going to write some example and we will try to solve it. Okay, sir, write it. First, see it very properly. What I have written, just understood. What I have written over here, like that. Okay, sir. Now why I have written this, see, understood it. Why I have written over here ki BH3 will give H. Suppose in hydroboration oxidation, they will write BD3 in presence of THF and H2O2 and NaOH. So what is the things coming? This will give D, deuterium, and this will give OH. Suppose I will change the reagent over here, D plus H2O. So this will give D, this will give OH. Suppose over here I will write HGOAC whole twice, D2O and NaBH4 NaOH. So what is the reagent coming? It will give OD, it will give H. So in place of H, they will change D. So you have to see where we will get OH. Suppose one will change the reagent like this. No sir, BD3 I will take THF, in presence of H2O2 I will take D2O2 in presence of NaOH. So this will give D, this will give OD. Understanding the point? So I have dictated what is the source of H and what is the source of OH. So BH3 is the source of H, NaBH is the source of H, and the H2SO4 is the source of H. Here source of OH is dilute, here the source or water, and here the source of OH is H2O2, here the source of OH is H2O. In place of H2O, if D2O given, they will write OD like that. I hope this much you understood, because you have seen my hydrocarbon topic, and hydrocarbon I have dictated you very, very properly. Okay sir, we understood. Give some example to make us more understood. Okay. Suppose first question I have written over here. कभी कभी मेरे दिल में ख्याल आता है. Over here I have written H plus H2O. कभी 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 I have written first reagent as HGOAC in presence of H2O, and second reagent as NaBH4 in presence of NaOH. Suppose I have taken the third is first HGOAC whole twice in presence of CH3OH. Second reagent NaBD4 NaOH. Acha sir. Third I have taken the reagent as first reagent B2H6 in presence of BH3 whole twice. BH3 written or BH3 whole twice written, same. Don't get confused. BH3 whole twice also be written over here. BH3 BD3 whole twice or BH3 whole twice, like that they will write BD3 whole twice. That can be also written as B2H6. Don't get confused. Second reagent H2O2 in presence of NaOH. And one more, suppose I will take last reagent is first BD3 in presence of THF. Second reagent is H2O2 in presence of NaOH. Any problem? No, sir. Now see over here. First of all, what it will give? H and OH. First of all, what it will give? It will give, from here we will get OH, from here we will get H. Okay, sir. In this part, H2O is not there, so this will come CH3O minus. From here we will get OCH3, and from here we will get D. Understanding na? Suppose I will take this, from here I will get H, from here I will get OH, from here I will get D, from here I will get OH. Now understanding what I am trying to say. Now H2O2 will form carbocation. Carbocation means it will break minus plus. There is a possibility of rearrangement? No. H plus is there, OH minus is there. So H plus will attack on the minus side and OH will attack on the plus side. This product is come. But this product has one chiral center. One chiral center means it has two stereoisomers. One is normal, one is mirror image. The 2 will be the answer. Understood the point? Ha sir, one on left side, one on right side. That much you know. Over here, it will form carbocation, done. It is acid catalyzed hydration. It will follow Markovnikov rule. What it will follow? Markovnikov rule. Markovnikov rule is saying that more hydrogen will get hydrogen, less hydrogen will get OH or something what it is coming. So over here, what you will get? Ringa, chinga, pinga. More hydrogen will get hydrogen, less hydrogen will get OH. Markovnikov's. Sir, same as the first one, huh? Because no rearrangement possibility, so same coming. It also has two answer. One is left side, one is right side. Mirror image type. Acha sir. Over here, what you will say? It will also follow Markovnikov's rule. Markovnikov's rule means more hydrogen will get hydrogen. But this time hydrogen is not coming. What is coming? D is coming. So what it will come over here? D. Acha. Over here, H2O2 will give OH. H2O will give OH, but H2O is not there. CH3OH is there. That will give OCH3. So this is the product coming. In this product again we have one chiral center over here. It also have two answer. Mirror image. Over here, it will follow anti-Markovnikov's rule. Lesser hydrogen will get hydrogen and more hydrogen will get OH, and this time at an OH is there. Is there any chiral center? No. So only one compound will form. BD3, it will also follow anti-Markovnikov's rule. What you will get? Ringa, chinga, pinga. Less hydrogen will opposite to Markovnikov's. Over here D will come. H2 needed to become, but H is not present. So what will come? D will come. What will come? D will come. So D will come here and OH will come here. Because over here D giving na, H not giving na. So it has chiral center. Yes sir, one chiral center over here because of D. So it will also give two product. Now understanding everyone. Any confusion? No sir, something coming. See it. Properly you will try to see it. Trust me, this is going to be very easy for you all. Okay sir, I am trusting on you. Second question. Suppose I have taken कभी कभी एक था राजा एक थी रानी उसकी बेटी फूल कुमारी फूल same reagent I am taking from here H plus H2O this I am writing dash. How many I have make? 1 2 3 4 5 I have make. So I will make 5 lines. 1 2 3 4 5 because I didn't have a space. So I will write all the time. That is a video na, that will take most time. Same as line by line I have taken. First reagent what I have taken? H plus H2O. H plus H2O carbocation it will form. Carbocation it will break like this plus and minus. Most stable carbocation rearrangement not required. So it will come ringa chinga pinga OH over here. H will be here. No need to write. If you want to write, write. Any problem? No sir. Does it has any chiral center? No sir. Because this carbon has this difference. But this side to coming same na. Nothing different, no chiral center, only one product will be there. Second, what is the reagent I have taken? HgOAc plus H2O NaBH4. This I am writing. Understanding na? Ha sir, understanding. Over here it will give H and OH Marconi-Cops rule. Again, Marconi-Cops rule, less hydrogen will get OH and more hydrogen will get hydrogen, only one product will form. Third reagent I have taken B2S6, H and OH, but anti-Marconi-Cops rule. Anti-Marconi-Cops rule means opposite to that. Over here coming what? 1, 2, 3, 4, 5. Third one is what? Acha, sorry. Third one is this one. This one. This I have written first one. Second one. This one is third one. Third one is OCS3 and D. OCS3 and D. So over here OCS3 will come. Where OH is coming, there OCS3 will come. And where H is coming, there D will come. Oh, sir, over here one chiral center, two chiral center. Because of two chiral center, 2 to the power 2 is 4 is the total product coming. Next part, I have taken what? B2S6, acha, anti-Marconi-Cops rule, but this will do syn addition. What it will do? Syn addition. Written now over here, especially for this hydroboration oxidation, syn addition. Ha, sir. So it will do syn addition. The problem is that we didn't know that this methyl is on base on dash. This methyl is where? This methyl is base or dash. So what you will say? That there is a possibility. I will think that this methyl, any one place I will think that this methyl is on base position. I will think like that. So what happened? H and OH has to attack by anti-Marconi-Cops. So H will come here, OH will come here. Another product, you will think, no sir, it may be this methyl will be on base position, dash position. We didn't know na where it is. So sir, why you have not done in this part? Because in this part, no possibility, only cyclic ring is there, then you will do. Then what happened? Remaining hydrogen will be here on the base and OH will be here on the base. So base, OH, syn addition coming. Last part, it is giving D and OH. Again it is Marconi-Cops rule, but syn addition. Again we will say, ki sir, we didn't know this CS3 will be on the base or this CS3 will be on the dash. So what I will do? I will say, okay sir, first I will put D here and OH here. D and OH coming. Second possibility that I will put this CS3 on the dash. So this D will come on the base and this OH will come on the base. Understood the point? What I am doing it? Everyone? Ha sir, understood. The 2 questions I have done. 2 more questions I will give you. 1 question I will give like this. All the reagent you will use. 1 question I will give like this. Here and here. First question, second question, homework question. Sir, what is the problem in first and second? No problem. First answer will be as it is, second will be as it is, third will be as it is. But whenever this will come, B2S6, H2O2, B2S6, H2O2, at that time syn addition. So syn plus trans, it is trans. So anti will come, syn plus cis. So it is syn will come. What will come? Syn will come. We will try to do that question and give me the comment on the comment section. If you have any doubt, I will dictate it again. Trust me. And I will dictate. I am not saying that I will need not see the comment and not say anything. I will dictate means I will dictate. Understood? So everyone will try this and try to understood this what I am trying to say and how is the one answer I will give. Suppose I will react with B2H6 in presence of THF and H2O in presence of NaOH, H2O2 in presence of NaOH. What you will say? Sir, over here CS3, this carbon, after that this carbon on the bottom CS3, it will do syn addition. It is trans is negative, syn is positive, positive negative will become negative. So there they will give H. So if H will come this side, they will give OH. So OH will come this side. Remaining 2 position already H is there. So this H and OH anti addition. Another possibility ki CS3, this OH will come this side. So H will come this side. Remaining H and H will be as it is. Understanding the point? This way happens. Anti addition means H this side, to OH this side. It is cis, it is syn. Cis is positive, syn is positive. So for this CS3 CH3HOH, same side. H and OH will be same side. So over here, no possibility of doing other things. Understood? You can't do it. You will say, sir, CH3 OH this side I will not take. H and OH this side. You can take it, no problem. But whenever you will cross check, these two will come identical. These two will come identical. But over here it will not come identical. Something it will come. Don't worry about it. So I hope, and remaining all will be as it is. So now I hope so. You will understood about the preparation of alcohol from hydrocarbon. Again I am saying, if you will find any difficulty, 9267937718 is my WhatsApp number. You can call, you can message me over here and ask me any one of the question if you are not able to get the solve. Understood the sir? Sir, we understood it. Okay. Now some place I have changed D. Over here you can change D. Like that, lots of question you can make. I hope you understood. That much brain to you have. You are studying alcohol. Phenol ether means you have already seen my lecture of hydrocarbon. You have already seen my lecture of GOC. You have already seen my lecture of isomerism. You have already seen my lecture of alcohol, alkyl and halide, alkyl and aryl halide. Then only you are coming here. If you have not seen, then suggestion. Trust me, I am giving very good content over here. I hope so. Lots of talented teachers are there in this universe. It may be they are giving much better than me. So you can see it over there also. It is not forceful. But if you are seeing from my lecture, the request, just a humble request, try to understood from beginning. If you don't want to see GOC isomerism, at least you will see hydrocarbon, as well as Grignard reagent, as well as haloalkanes, haloarenes, as well as electrophilic aromatic substitution. This 4 topic I have completed in one shot, as well as part by part also. Your choice. See, organic chemistry will become very easy. Now, next method of preparation is from alkyl halide. Next method of preparation of alcohol, hydrocarbon done. And I have given almost all the question possible that will be a chance of coming in the exam. So from alkyl halide. Now in alkyl halide saying that suppose we have alkyl halide, they will react with NaOH, or this alkyl halide will react with H2O. So what it will give? It will also give OH, it will also give ROH. But you have to remind one thing, it will follow SN2 when R is 1 degree and 2 degree, and it will follow SN1 when R is 2 degree and 3 degree. When R is 2 degree and 3 degree, and SN1, SN2, sir, you are always saying to see that video, how I will understood it? If you know SN1, SN2, no problem. Not known, hydrocarbon, you will see I have dictated over there total detailing. All nucleophilic substitution I have dictated SN1, not hydrocarbon. I have dictated that in alkyl and aryl halide. SN1, SN2, SN1 prime, SN2 prime, SN1 Ng, SN aromatic, SN2 aromatic, SN intramolecular, SNI prime, like that. Lots of SNEA, SNAE, lots of things I have dictated. So if, sir, what happen if this is 3 degree? Then 3 degree always, without any confusion, SN1. 1 degree always, without any confusion, SN2. If they are doing nucleophilic, if they are doing elimination, don't say that. Means nucleophilic substitution, 3 degree is always SN1, 1 degree is always SN2. But over here 1 degree and 2 degree will do SN2, and over here 2 degree and 3 degree will do SN1, NaOH, and H2O is there. Acha sir, tell me some questions on this basis. Okay, suppose I have written the first question over here, कि we will have Me CH2CH3 HCl, and I am saying react this first with NaOH, react this second with H2O. What you will say? Sir, this is 2 degree, one side methyl, one side ethyl, so it will follow SN2 and it will follow SN1, because 2 degree I have written, 1 degree to always SN2. Now SN2 means what? Inversion. Inversion it will do. Back side, what is the product coming? Me, bottom side is ET, CH2, CH3 is ET, H will come this side, OH will come this side. It will form inversion product, only one product, but it will form retention and inversion both. So it will form retention and inversion. What you will get? Me, Et, H, OH, one product. Me, Et, H, OH, another product. Two product will come because SN1 is there. And when you will put the mirror over here, you are getting this two product is looking like enantiomers. Enantiomers pair. The enantiomers pair will do racemic mixture, racemization. This is optically active, this is optically active, but racemic mixture is optically inactive. GOC, lots of things you know that already about this. Haan sir, no need to dictate that. Trust me, what I am teaching na. Acha, leave it, don't show off too much sir. Acha, okay. Suppose I have written over here Vase, methyl, and over here Cl, and I am saying react with NaOH first part and second part react with H2O. NaOH will do SN2 because this Cl is 2 degree. It will do SN1. Acha. SN2 means inversion. CH3 will be not touched as it is, and Cl will go into outside and OH will attack, and that OH will attack on the wedge position, not on the dash position. Why? Because already Cl is on the dash position. For here, what you will do? First you will remove Cl, then it will become carbocation. After getting carbocation, it will do rearrangement. Over here hydrogen is there, they will break as a minus, it will become plus, hydrogen will come here. Don't say wedge and dash directly. So rearrangement happen. After rearrangement, it will become positive, and on this positive the OH will attack, and what you will get over here? Ringa chinga OH. Sir, over here wedge dash will not happen. No, because someone is already sitting on the wedge position. So if no one is sitting on the wedge, then wedge dash product OH will come. I hope you understood what I am trying to dictate regarding this. So second method of preparation also done from alkyl halide. Now we are going to see the next part of the topic, that is called reduction of carbonyl compound. Next method of preparation of alcohol is reduction of carbonyl compound, and trust me, I will make this topic that much easy. You will enjoy this topic if you will study very properly and you already know little bit about GOC, hydrocarbon, all the things. Okay sir, okay sir, okay. So first topic we have seen preparation of alcohol from hydrocarbon, and second we have seen preparation of alcohol from alkyl halide. Third we are going to see from a reduction of carbonyl compound. Preparation of alcohol from the reduction of carbonyl compound. What is carbonyl compound? Just understood it. Sir, we know carbonyl compound. Okay, I know that you are talented, but still I will dictate you. Carbonyl compound means C double bond O is there. Over here something, over here something. Any compound that will contain C double bond O, that is known as carbonyl compound. Now, over here, whenever you will do the reduction of carbonyl compound, over there you will have to use the reagent as metal hydride. What do you have to use? Metal hydride. Metal hydride means M plus H minus. M plus H minus. And especially reduction of carbonyl compound we will do for aldehyde and ketone. Especially we will do the reduction of carbonyl compound for aldehyde and ketone especially, and reagent we will use as a metal hydride. What we will use? Reagent metal hydride. Before starting this topic, you have to understood over here that we have H minus, and any minus is known as nucleophile. If we will have any nucleophile, that nucleophile first wants to do acid-base reaction. Any nucleophile first wants to do acid-base reaction. After that, if acid-base reaction not possible, then they will do pi bond reaction. If pi bond is also not possible, then they will do sigma bond reaction. Understanding the point means any nucleophile H minus is there, they will first of all reduction of carbonyl compound, especially carbonyl compound is C double bond O, especially for aldehyde and ketone we will take over here reagent we will take metal hydride M plus H minus. Now before starting that topic I am saying if you will see any nucleophile, that nucleophile first try to do acid base reaction. If acid base reaction not possible, then they will try to attack on pi bond. If pi bond not possible, then they will try to attack on sigma bond. Not here, every place this is the power of nucleophile. Suppose I will give one example, R C double bond O OH. Now either you will take H minus nucleophile, or you will take R minus nucleophile, or you will take R del minus nucleophile, or you will take OH minus nucleophile. Any nucleophile you will take. First you will try to do acid base reaction, and this carboxylic acid has acidic hydrogen. It will react here, it will react here, it will react here, and it will react here. Everyone will try to do acid base reaction. It will give H2, it will give RH, it will also give RH, it will give H2O, but what is left? R C double bond O minus, and you know that this R C double bond O minus is doing resonance. Over here partial double bond coming, over here partial double bond is there, over here also we will have partial double bond, over here also we have negative, and they will do resonance over here, and these types of resonating structure is known as equivalent resonating structure. And equivalent resonating structure is a very good acidic strength. If after removing hydrogen any compound is giving equivalent resonating structure, it means that compound is good acidic nature, good acidic nature. Why? Because after giving acid, that is H plus, it is forming the equivalent resonating structure, so it is a very good acidic nature. So over here, if possibility, then it will first try to do acid base reaction. If no possibility, then it will not try to do acid base reaction. Okay sir. So carboxylic acid to doing acid base reaction. Suppose I have taken aldehyde C double bond OH and ketone R C double bond O R. Now tell me over here any place acidic hydrogen? No acidic. Don't say this is acidic. Acidic hydrogen means after removing hydrogen, that will be stable. No acidic hydrogen is there. Okay. But this carbon and oxygen has electronegativity difference. Because of that, it will get little bit del plus, it will get little bit del minus, it will get little bit del plus, it will get little bit del minus. Now what happened? Ki H wants to attack over here, H minus is there. H also wants to attack over here. Now H wants to attack over here. This side CS3 is giving plus I effect. R is giving, understood. I am saying over here acid base reaction is not possible. If acid base reaction is not there, then it will try to attack on pi bond. It will try to attack on pi bond. So over here pi bond is there. Pi bond, it will take little bit negative charge, positive charge due to electronegativity difference. Now H minus will try to attack over here. H minus will try to attack over here. Now whenever it is trying to attack, what will happen? This before attacking, before H plus will attack, what is happening? Del plus creating, del plus will be stable over here by R plus, but it is stable over here by both side R plus. So it will say, okay, no problem, I am little bit stable, attack little bit slow, no problem. As well as it has less steric hindrance, it has more steric hindrance. So which has more rate? Aldehyde. It means rate of reduction of aldehyde to form ketone is more than, rate of reduction of aldehyde to form alcohol. It is forming what? Alcohol. Rate of reduction of aldehyde to form alcohol is more than ketone. First reason is what? Due to less steric hindrance. Due to less steric hindrance. Due to less steric hindrance. Why? Because over here only one side R is there. Over here two side. Second important point, this plus is not stable because only one side. This plus is more stable. So due to high electropositivity in aldehyde, due to high electropositivity. So in aldehyde, less steric hindrance and high electropositivity. So aldehyde has more reduction capability in presence of H minus as compared to ketone. So I hope you understood this. Now you can write over here one short tricks, but don't believe on short tricks. I will dictate it also. And dot short tricks is that ki aldehyde, whenever it will react with metal hydride, it will give 1 degree alcohol. Aldehyde react with metal hydride, it will give 1 degree alcohol. But whenever ketone react with metal hydride, it will give 2 degree alcohol. It will give 2 degree alcohol, and this is the important part of the topic. Now, sir, you said it is the short tricks, but I don't want the short tricks. Dictate me how you are saying it. Suppose I will take aldehyde, C double bond O H. First reagent H minus is coming. What is coming? H minus is coming, and second reagent H2O is coming, and it will convert into RCH2OH. How, sir? Reaction you have written directly. Let me understood also. Okay, don't worry. RC double bond OH is there. First of all, H minus will come. H minus you have already seen this has del negative. Little bit it has del positive, negative it has del positive. On this del positive it will attack. Once it will attack, RCH is coming. Over here H, carbon is getting one more bond, so it will break. Carbon does not make 5 bond, so it will become RCH and O minus. O minus say, no, I want to return back, give me some space. So this H will say, no, I am not a living group. This H will say, aisa, bhai sahab, I am also not a living group. This R will say, nahi bhaiya, I am totally not a living group. So this O minus is totally worried. So at that time, H2O will come, and H2O or NH4Cl. Both will give H plus. How? H2O, so we know that, sir, H plus OH minus. How NH4Cl? NH4 plus Cl minus, then NH4 plus converted into NH3 plus H plus. So both is the donor of H plus. Once the H plus will come, it will become very happy, and it will become R, C, OH, H and H. And you have seen over here ki I can write this R, CH2, OH, and this alcohol is 1 degree alcohol. So I have written ki aldehyde will give 1 degree alcohol. Acha, suppose we have ketone. Ketone we have RC double bond OR. Now again H minus will come first from metal hydride. What are the metal hydrides, sir? Wait, I will dictate it. H2O will come. What will happen? First of all, it will get del negative. H minus will attack. It will get more bond. Minus will attack. It will give H plus. H plus will attack, and you will get R, C, OH, over here H and R, and it will give 2 degree alcohol. So I hope you understood the reduction of alcohol, reduction of aldehyde and ketone to produce alcohol. Now question arises, what are the metal hydride we will see? So what are the reducing agent that we will see as a metal hydride? And we are going to talk about the metal hydride. That metal hydride is act as a reducing agent because it is giving H minus to the compound, and H coming is what? Reduction. So metal hydride is a reducing agent. What are the reducing agent and what are the metal hydride we are using over here? Just see it. What first metal hydride I am using? Very important. First metal hydride I am using over here is कभी कभी मेरे दिल में LiAlH4, that is also written as LaH. LiAlH4, that is also written as LaH. Li plus, and it will give Al, H, 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 and aluminum has minus. Over here H will go, minus will go from here, and it is more reactive. And it has 4 hydrogen. So how many hydrogen required? It will give, and it can reduce each and everything. I will tell you what. First LiAlH4. Second one, is NaBH4. That can be written as SBH, sodium borohydride. Sodium borohydride. If you will draw the structure same, NaBH, H, H and H, it will get over here minus sign. The hydrogen will go from here, minus will be stable. So, but understood the point. It will only react, means SBH has also lots of hydrogen. I will tell why I am saying lots of hydrogen. I will tell that also. First understood this part. With question I will understood. It can reacts only with aldehyde, ketone, acid halide. Acid halide. Acid halide is C double bond O Cl and C double bond N, that is known as imine. Rather than that, it will not react with anyone. This is fixed. This is totally fixed. These four only it will react: aldehyde, ketone, acid halide and imine, C double bond N. Remaining it will not react. It also has lots of hydrogen source. Fourth one is dibyl H. Dibyl H. That is also known as dibyl H, means di-isobutyl aluminum hydride. Dibyl H means di-isobutyl aluminum hydride. That is also written as aluminum isobutyl whole twice and hydrogen. Sir, what is the structure? Aluminum is there, here hydrogen, over here isobutyl and over here isobutyl. Di-isobutyl aluminum hydride or hydrogen Al, over here isobutyl means 1 2 3 4, over here 1 2 3 4, di-isobutyl aluminum hydride. Now it will give also hydrogen because it has more bond, it will give hydrogen, and over here only one H, only one hydrogen. It has 4 hydrogen, it has 4 hydrogen, but di-isobutyl aluminum hydride has only one hydrogen. What is the use of that? That I will dictate it. Fourth reagent we have is B2H6 in presence of THF, that is also written as BH3. Next reagent is H2 catalyst. H2 catalyst will do adsorption hydrocarbon. हाँ sir, what is there? RC double bond O, RC double bond O, C double bond O and H is there. What you will do? You will take nickel or platinum or palladium catalyst. Over here hydrogen molecule you will put, this 2 will come and hydrogen will attack over here, hydrogen will attack over here. Then will do syn, and over here rate is more in palladium, then platinum, then nickel. Nickel will do little bit slow. So these are the total 5. These are the total 5 metal hydride, that is reducing agent. In that LiAlH4 is very more reactive. This NaBH4 will only react with this 4, and dibyl H has only one hydrogen, and remaining 2 is B2H6 and THF and H2 and catalyst. Understood? Now on this basis I am going to do some questions, then we will go with the further topic. Suppose first question I have taken, न जाने मेरे दिल को क्या 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 हो गया. कुछ नहीं हुआ सर, आप ऐसे ही बेचैन रहते हो. उम्र हो गई आपकी लेकिन दिल अभी भी धड़कने को तैयार है. अरे बच्चों के रिजल्ट के लिए धड़कता है, आप लोग तो पूरा यू आर वेरी डर्टी माइंडेड. अरे नो सर, वी आर नॉट. सपोज ओवर हेयर फर्स्ट reagent I have taken LaH. Second reagent I have taken H2O. Second part. Over here first reagent I have taken SBH means NaBH4. Second reagent I have taken H2O. Over here third reagent we have taken, first part is suppose B2H6 in presence of THF, and second reagent is H2O. Over here, third reagent we have taken, suppose first one NaBH4 and second reagent is D2O. Fourth reagent we have taken H2 in presence of nickel, and fifth reagent we have taken dibyl H in presence of H2O. First reagent, second reagent. First question. Second question I have taken like this, kabhi 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 double bond O, ringa chinga CHO, ringa chinga pinga COO CH3, and I have taken two reagent only over here. One is NaBH4 first reagent, and second reagent is H2O. Over here I have taken first reagent LiAlH4, second reagent is H2O. Now what I have taught, on this basis I am going to solve these two questions, but I am going to give you one break. What is the break? Break is the stoppage of this topic. Already 50 minutes is there. Those who have reached up to this, they can just see it properly. After that I will continue this topic in next lecture. Understood? Sure short? हाँ sir, understood. Means these two questions I will do, but not in this lecture, next lecture. So up to this you will revise. Next lecture you will see how I am doing it, because already 51 minutes completed. So I don't want to give you that much more. So up to now you will revise. These two questions I will solve in the next lecture. Okay. Bye. Have a nice day.